Hello, this is Dr. Hanaa Assil, and today we're doing questions and answers on some types of reactions. So we're doing on oxidation reduction reactions and reversible reactions. So this is the first question. The first question says chromium 3 oxide. Chromium is made by this reaction, and the first thing he says is write a chemical equation for this reaction. By now, you should be able to write chemical equations. Chromium 3 oxide will be chromium with a valency of 3, and we said the valency of something goes under the other. Oxygen has a valency of 2, plus aluminium to give chromium plus aluminium oxide. Again, aluminium is in group 3, so its valency is 3. It goes under the oxygen, and the oxygen is in group 6, so valency 2. Again, I'm reminding you, if he says write a chemical equation, he means a symbol equation, not a word. And then any symbol equation must be balanced. So you need to balance this equation. We count before the arrow, after the arrow, and we increase the one that is less. So before the arrow, I have 2 chromium, so I need 2 in front of the chromium. After the arrow, I have 2 aluminium, so I need 2 aluminium. So this balances the equation. Now explain why the reaction between chromium oxide and aluminium is described as a redox reaction. I'm going to remind you that the word redox means it has oxidation and reduction. So if he says, why is a certain equation redox? You have to tell me because so-and-so was oxidized and the other one was reduced. So which one here was oxidized and which one was reduced? You should remember that the chromium lost oxygen, and that means it was reduced. Now the aluminium gained oxygen, and that is oxidation. Okay, the next question says the reaction of sodium to form sodium oxide can be described as oxidation because it involves addition of oxygen. So sodium to sodium oxide, the sodium added oxygen or gained oxygen. Now state one other reason why this reaction can be described as oxidation. Remember we said oxidation is gain of oxygen or loss of electrons. So when the sodium reacts to form sodium oxide, it changed from Na to Na plus. That means that the sodium atoms lost 1 electron each, and that also is oxidation. The next question says, when chlorine gas is bubbled into an aqueous solution of potassium iodide, the colorless solution turns brown. So he's passing chlorine gas through something iodide, potassium iodide, sodium iodide, and of course these are compounds of metals that are not transitioned. So the original solution of potassium iodide, for example, is a colorless solution. Now, when we pass chlorine through it, you should realize that chlorine is more reactive than iodine. So it will displace the iodine from the potassium iodide to form iodine as a molecule, and the chlorine changes to chloride. Now we need to balance, so we need to put a 2. What is the name given to this type of reaction? Now what has happened? The chlorine gained electrons. It became Cl minus. Or we say that its oxidation number decreased from 0 to -1. That means the chlorine in this case was reduced. Now what happened to the I minus? The I minus changed to I2. So either we say that the I minus lost electrons, or the I minus changed oxidation number from -1 to 0, and that means that this is a redox reaction. You can also regard it as a displacement reaction because we said chlorine is more reactive than iodine, so it displaced it from the potassium iodide. Why does the solution turn brown? Well, of course, this reaction formed iodine aqueous. That's iodine solution. You should realize that iodine solution is brown. So it turned brown due to the formation of iodine, which is brown. The equation for conversion of this into titanium chloride, explain which element has been oxidized. Now we look at what has happened to each one. TiO2 changed to TiCl4. Cl2 changed to TiCl4. Carbon changed to carbon dioxide. Now, which one is oxidation? We said the one that has gained oxygen. So the carbon is the one that has been oxidized because it gained oxygen. The next question says the equations for some other reactions used in the manufacture of ammonium nitrate are so and so. Explain which two of these are redox reactions. Again, let's remind ourselves, what does redox reactions involve? They either involve gain or loss of oxygen, gain or loss of electrons, gain or loss of hydrogen, or increase or decrease in oxidation. So which reaction has at least one of these factors? Of course, if you look at reaction 3, what happened to nitrogen is that it gained hydrogen. And remember that we said when something gains hydrogen, it is a reduction reaction. Reaction 4, the NH3 changed into NO. That means the nitrogen gained oxygen, and that means that we have an oxidation reaction. Now, what about 5 and 6? Well, reaction 5 is just changing NO2 to N2O4. So each NO2 means each nitrogen has 2 oxygens. Now, when it changed into N2O4, it's still each nitrogen has 2 oxygens. So really, we did not gain oxygen. Reaction 6 is a reaction between ammonia and nitric acid. Of course, you should know that ammonia is a base. So this is a reaction between a base and an acid to give a salt. This is not a redox reaction. This is a neutralization reaction. Okay, let's look at this. Explain why this reaction is described as redox. Again, when he says that, you have to tell me where is oxidation, where is reduction. Well, if you look at the reaction, you should realize that the bromine changed to Br minus. That means the bromine gained electrons, and that means it was reduced. Now, the Fe2 plus changed into Fe3 plus. So either you say this is due to loss of electrons or to increase in oxidation number. Remember, Fe2 plus has an oxidation number of +2. Fe3 plus has an oxidation number of +3. So that is increase in oxidation number. Oxidation. Okay. So let's go on and discuss some questions and answers about reversible reactions. So this first question says the reaction to make ammonia is reversible and can reach a position of equilibrium. The graph shows the percentage yield of ammonia at equilibrium and at different temperatures and pressures. So in this graph, he's actually changing two things. He's changing pressure. So as we move from 0, 100, 200, 300, 400, we're increasing the pressure. So we have a graph that shows what happens when we increase the pressure. But then we have another graph that gives at a different temperature and a third graph that gives at a different temperature. So he's changing temperatures and he's changing pressure. Now he's saying state the conditions of temperature and pressure that would produce the largest percent yield of ammonia. Where did we get the largest amount of ammonia? Okay, first of all, was it at low pressure or at high pressure? Well, you can see that as we go from 0 to 100 to 200 to 300 to 400 atmosphere pressure, the percent yield of ammonia is increasing. So we have the highest percent ammonia at 400 atmospheres. Then we have three temperatures, 550, 450, and 350. Where do we have a higher yield? The one at 350 degrees Celsius. Find the percentage yield of ammonia at equilibrium at a pressure of 200 atmospheres and temperature of 450. So you look at the graph and you take a look. Where is the 200 atmospheres and the 450? Well, according to this graph, the percent yield was 40%. Suggest why in the industrial process the percentage yield of ammonia at 200 atmospheres and 450 is only 15. So the graph says it should be 40 from what we got from the graph. But then he said, actually, when we do it in the lab, I get only 15%. Why do you think that may happen? Well, That means that the reaction is not equilibrium. Remember that the graph is showing me the percent ammonia I would get at equilibrium. So if you don't get the 40% that you're supposed to get, then the reaction is not at equilibrium. This other question says the table shows the formula and color of 3 different types of cobalt-2 chloride. So he has a cobalt-2 chloride that is blue, a cobalt-2 chloride with 2 water of crystallization, that's purple, a cobalt-2 chloride with 6 water, which is pink. Now, when water is added very slowly to the solid CoCl2, the color changes from blue to purple and then pink. First of all, write a chemical equation for the change from purple to pink. He already gives you the formula of the purple and he gives you the formula of the pink, and this should be a reversible reaction because you can heat them and remove the water. So to change from the 2 water to the 6 water, that means you added 4 molecules of water for each molecule of that purple compound. So this would be your equation, and do not forget to put the reversible sign because we move from one type to another. That is what he's telling me in the equation. Ammonia is used to produce nitric acid. The first stage of the process is shown in this equation. Now state why using a lower temperature will produce a higher yield of nitrogen monoxide. Again, I'm going to remind you, when we have a reversible equation, we said we can change either temperature or pressure if they're all gases, or concentrations of reactants or concentration of products in order to cause a reaction to go more forward or more backward. If we're changing the temperature, so here he's saying I'm using a lower temperature. Again, remember when we were talking about reversible reactions, a lower temperature will cause the reaction to go to which side? Lower temperature goes exo. Higher temperature goes endo. We said the reaction will go to the side that is opposite to what you're doing. So if you're trying to heat it, it will try to cool itself. If you're trying to cool it, it will try to heat itself. So remember that using a lower temperature in any reversible reaction causes that reaction to go to the side that is exothermic. Now, how do I know which side is exothermic? From the sign of the delta H that we have at the end of the equation. So this equation that he gives me, he has delta H is a negative number. That means as I go from ammonia plus oxygen to give NO plus water, this reaction is exothermic. That means it will become hotter, and that means if I want to go forward, I should lower the temperature. So lowering the temperature in this reaction will cause the reaction to go forward, since the forward is exothermic, as is indicated by the negative sign of the delta H. Okay, then he says, states why using a lower pressure would produce a greater yield of NO. Now, we said, if I'm looking at temperature, I look for which one is exo and which one is endo. But if I'm looking at pressure, I don't care which one is exo or which one is endo. When we're looking at pressure, we look at which side has more molecules or less molecules. Remember that we said for any reversible reaction, increasing the pressure will cause it to go to the side with less molecules. So lowering the pressure will cause it to go to the side with higher number of molecules. So let's look at this one. If I go forward, I form 4 molecules of NO and 6 molecules of water, so a total of 10. If I go backward, I form 4 molecules of ammonia and 5 molecules of oxygen. That's a total of 9. So that means if I lower the pressure, it goes to the side with more molecules. That means it goes forward and it gives a higher yield of NO. Okay? This other question says something called phosgene is used in industry to make polymers. And he says phosgene is formed when carbon monoxide reacts with chlorine, and he gives me the equation. The reaction mixture is kept at temperatures between 50 and 150. If a temperature above 200 degrees Celsius is used, only a small amount of phosgene. So just why only a small amount of phosgene is formed at very high temperatures. Again, if I'm going to raise the temperature of any reversible reaction, then the reaction will go to the side that is endothermic. Now, which one is endothermic here? He says the forward has a delta H of minus 108. That means the forward is exo. So if I increase the temperature, it will go backward or it will shift to the left. And that means it will give less of the COCl. Do we understand that? Raising the temperature goes endo. So here I'm going to raise the temperature, it will go backward. Predict how the yield of phosgene will change if the reaction is carried out at higher pressure. Now, at higher pressure, what happens? At higher pressure in any reversible reaction, higher pressure will cause the reaction to go to the side with less molecules. So if I increase the pressure here, I go forward, it gives one molecule of COCl2. If I go backward, it gives one molecule of CO and one molecule of Cl2. That means it gives two molecules. So in this reaction, if I increase the pressure, it will go forward because this is where I have less number of molecules. Okay. This next question says hydrogen iodide can be manufactured from its elements at temperature of 500 degrees Celsius and pressure of 480 M, and platinum catalysts are used. A manufacturer carries out this reaction using the same catalyst but and a pressure of 4, so it's the same pressure, but what he's doing is instead of 500 he's going to use 400. That means he's lowering the temperature. Again, lowering the temperature causes it to go to the side that is exo. Lowering the temperature goes exo. Explain the effect on the yield. Now, if it goes exo, which one is exo here? He says the forward is delta H is minus 9. That means the forward is exo. That means if I lower the temperature, it causes it to go forward or shifts to the right because it is exothermic, and that means I get a higher yield of HI. Then he says the manufacturer then carries out this reaction at temperature of 500 but at a lower pressure. So he's decreasing the pressure. We said when we decrease the pressure, what happens? If we decrease the pressure, it will go to the side with more molecules. Increasing pressure goes less molecules. Now, if I decrease the pressure here, where is the more molecules and less molecules? Well, going forward gives me 2 molecules of HI. And going backward would give me 1 molecule of H2 and 1 molecule of I2. That means 2 molecules also. That means I have the same number of molecules on both sides. So changing pressure will have no effect on the yield because there is equal number of moles on both sides. Going forward, it's 2. Going backward, it's 2. So this will not affect the point of equilibrium. It will not affect the amount of hydrogen iodide that I get. Okay, this one is a simple question. He's just saying, what does this sign mean? Always remember that this sign means that the reaction is reversible. Okay, then he says, for this equation of nitrogen plus hydrogen to give ammonia, predict the effect of higher temperature on the rate. Please remember, is he asking about effect on rate? In that case, you'll tell me the rate is faster or slower. Or is he asking the effect on equilibrium? Equilibrium position means it will go more forward or go back more backward. Now, the first question says, what is the effect of higher temperature on the rate of reaction? Remember, any reaction is faster when you increase its temperature. Any reaction, if we're talking about rate, increasing temperature increases the rate. But then If he's saying what is the effect of higher temperature on equilibrium position, that means will it go forward or backward? Remember we said increasing the temperature will cause it to go to the side that is endo. Higher temperature goes endo, lower temperature goes exo. So the higher temperature will go endo. Now is the endo here forward or backward? Well, if delta H is minus, that means the backward is endo, and that means it will go backward or it will shift to the left. Predict the effect on equilibrium of increasing the pressure. Again, we said increasing the pressure of a reversible reaction will cause it to go to the side that has less molecules. Where do I have less molecules? Going forward gives 2 molecules of ammonia. Going backward will give you 1 mole of nitrogen and 3 moles of hydrogen. That's 4. So in this case, increasing the pressure will cause the reaction to go forward or shift to the right. So this will allow it to give less number of molecules. This question says, he's talking about the same reaction, nitrogen plus hydrogen to give ammonia, and he says this reaction is done at a pressure of 200 atmospheres and temperature of 450. Why is a catalyst needed? Remember, what is a catalyst? A catalyst is a substance that speeds up the reaction. So we need the catalyst to speed up the reaction. What is meant by dynamic equilibrium? Do you remember we said what is dynamic equilibrium? We said the reversible reaction will keep going forward and backward until it reaches dynamic equilibrium. What is dynamic equilibrium? This is when rate of forward reaction equals rate of backward reaction and concentrations of both reactants and products remain constant. Another question, he has ICl plus Cl2 to give ICl3. The ICl is dark brown and the ICl3 is yellow. The reaction mixture is allowed to reach a state of dynamic equilibrium. When the equilibrium mixture is heated, it becomes darker brown. So looking at that equation, when I heated it, did it go forward or did it go backward? He's telling me it became darker brown. That means it went backward or it shifted to the left. Now, explain whether the backward is exo or endo. If I raise the temperature and it goes backward, that means the backward is endo, because we said raising the temperature will cause the reaction to go to the side that is endo. And that's why it gave more ICl, and that's why the color became dark brown. This reaction is about nitrogen dioxide, which is a brown gas. It changes into dinitrogen tetroxide, which is a colorless gas. Now, the two gases can exist together in dynamic equilibrium. A mixture of nitrogen dioxide gas and dinitrogen tetroxide gas is allowed to reach equilibrium in a sealed container at 20 degrees Celsius. Then he says the equilibrium mixture is brown. The sealed container is immersed in hot water at 60. That means he's heating the reaction. As the temperature of the gas mixture increases, the pressure of the gas also increases. Predict the effect of increase in temperature. Okay, so if I increase the temperature on this reaction, will it go forward or backward? Remember we said increasing the temperature will go endo. Which side here is endo? If he says that the forward has a delta H of minus 58, that means the endo is the backward reaction, and that means the reaction goes backward or it shifts to the left. Predict the effect of increasing pressure on the position of equilibrium. Well, we said if we increase the pressure, the reversible reaction will go to the side that has less number of molecules. So in this one, if I go forward, it forms 1 molecule of N2O4. If it goes backward, it forms 2 molecules of NO2. So in this case, increasing the pressure will cause the reaction to go forward or shift to the right. Now, suggest why it's difficult to predict which way the equilibrium will shift. Remember that he said he's raising both. He's increasing temperature and he's increasing pressure. Well, we said if he increases temperature, it should go backward or to the left. If he increases pressure, it should go to the right. So overall, will the reaction go to the left or the right? Well, it's difficult to determine because we don't know which one has greater effect, the temperature or the pressure. suggests why the equilibrium mixture is a darker brown. So if he says that he has this reaction, and we said that the NO2 is brown and the N2O4 is colored. Now he's saying at 60 degrees, the color becomes brown. So did he go forward or backward? If it goes brown, that means it went backward. More NO2 is formed. So that means that the effect of temperature is more than the effect of pressure. Because remember, we said if you increase the pressure, it should go forward. But if overall the reaction went backward, that means the effect of increasing temperature is more than the effect of pressure. This question says when nitrogen dioxide gas is placed in a sealed flask, it reacts to form dinitrogen tetroxide. A sample of pure NO2 is placed in a sealed flask at 25 degrees Celsius. The flask is left until dynamic equilibrium is reached. Then he says at equilibrium, there is more NO2 than N2O4. Are you following? At the beginning, he had only NO2. So the number of moles of the NO2 was very high. And then it started to break down to form N2O4. So the amount of NO2 started to go down until we reached equilibrium. So he's saying draw a cross on the graph at the point where the reaction reaches equilibrium. You should realize that the reaction reaches equilibrium at the point where it is no longer changing the amount of NO2. Now draw a curve on the graph to show how the number of moles of N2O4 changes. He is telling me that at the beginning I didn't have any N2O4. I started with pure NO2. That means the amount of N2O4 at the beginning was 0. And then some of the NO2 started to form N2O4, so the amount of N2O4 should increase. And then he says at equilibrium there is more NO2 than N2O4, so this is the kind of graph that you would draw. Please listen to this, stop it at any time, and go over what we're saying. Make sure that you understand what we're saying. Then he says the sealed flask containing the equilibrium mixture is placed in water at a temperature of 50. So at the beginning, it was at 25. When he put it at 50, that means he's raising the temperature. And he says that the mixture goes darker. That means when he raised the temperature, did it go forward or backward? If it goes darker, then that means that at the higher temperature, it went backward. Now explain what this observation shows about the equilibrium reaction. Well, I raised the temperature and it went backward. And we know that raising the temperature, the reaction goes to the endothermic side. That means that the endothermic side is the backward reaction. So increase in temperature shifts the equilibrium to the left. It gave more NO2. That's why it became darker in color. And that means that the backward reaction is the endothermic reaction. This other question says we have carbon monoxide and hydrogen used in manufacture of methanol, and he gives me the equation, and he says the reaction is carried out at a certain pressure and a certain temperature. And the first question is state two features of a reaction that is in dynamic equilibrium. Again, if he asks about what is dynamic equilibrium, remember we say rate of forward reaction equals rate of backward reaction, and concentrations of reactants and products remain constant. These are the two features of a reaction in dynamic equilibrium. How would a decrease in temperature affect the amount of methanol? So if I decrease the temperature, decreasing the temperature means, remember, when we decrease the temperature, the reversible reaction goes to the side that is exo. Lower temperature goes exo. Higher temperature goes endo. So if I decrease the temperature, it goes exo. Now, which side here is exo? He's telling me that when CO reacts with hydrogen to form methanol, the delta H is minus 91. That means going forward is an exothermic reaction. And that means when I decrease the temperature, the reaction goes forward, and that means it will give more methanol. Since the forward reaction, that is the exothermic reaction. How would an increase in pressure affect the amount of methanol? Again, let's look at the equation. We said if I increase pressure, the reversible reaction goes to the side that has less number of molecules. If we increase pressure, it goes to less number of molecules. So if it goes forward, it gives 1 molecule of methanol. If it goes backward, it will give 1 CO and 2 H2. That means 3. So in this case, increasing the pressure will go forward to give less number of molecules, and that means it will give more methanol, so the amount of methanol increases. Thank you for listening. I hope this has made this topic a little bit easier. Please go over the video that explains the lesson and this one in order to understand what we're talking about. Thank you for listening.